Okay, good afternoon, people. It's 4 o'clock. Let's get going. Start of week 5. This is going to be my 15 minutes. There is something that came up by one of the students. Apparently, there was a typo on the assignment sheet, assignment number 4. By mistake, I made a cut and paste here, so it said something about Friday. That was not your lab, so I fixed it. This homework, assignment 4, is 24 hours after the end, due 24 hours after the end of this uh, tutorial of yours. Okay, so by tomorrow at 7 o'clock, the GA must receive this. Now, one other thing. I noticed that the problem that you have to submit, this is lab 53, is okay. I mean, basically, it's something that we have covered. I have put this thing on YouTube. You probably watched it and did it. However, for the lab 54 that I'm going to meet tomorrow, they have to turn in this problem. Now, I had not done a problem on temperature, and I'm going to, because of that, today, I'm going to do this problem at the end. Now, you don't need it, and even if you need it, it's already on YouTube, okay? This is already posted there, except that the people in 54 might say, okay, well, you know, we have to turn in this today, and you did not even discuss it in class. Fine. So for those people tomorrow, just like I'm doing it today, I will discuss this problem that I'm going to do right now, and then followed by that problem. It's exactly what I'm going to do with you. Okay, are there any questions before we move on? All right, no questions. So you see this thing on the test, you immediately should realize that this is an assembly problem. Not only that, it's an assembly of parts made of, bulky parts, let's put it like that. An assembly of parts that need to be meshed with those solid elements. When I say solid elements, Katia called it tetrahedral element. Okay? Now, there may be one or two people in this class that they decide to do this thing differently as an assembly. And believe me, if you do it right and everything comes out, everything I mean, then you get full mark. But it's very unlikely that you can get it going. Okay? Listen, I'm going to say that and I'm going to ask you to erase it from your memory. In principle, this can be modeled as a shell with that thickness and these as beams with that cross section. Don't do it, because 99% of you guys cannot finish this. So when you see something like that, you realize that this, for you, has to be modeled with solid elements. Okay. The ends of this are clamped, and we take these end faces, it's kind of vague here, these end faces, and move it up by 0.01 inch. Okay? That's something that in reality cannot be achieved the way I'm describing it, but that's what we're going to do. You do what what the problem statement says. Okay? Okay, now, do you see any planes of symmetry here? Because remember, a big chunk of your mark is identify any planes of symmetry, if at all. So do you see any planes of symmetry here? Can you say it if you're trying to say something?
It's the YZ plane right down the middle.
Very good. Very good. Anything else?
You could even do it XZ plane right down the middle as well.
That's it. You have to do with both of them if you want full mark. If you want full mark, you have to do both of them. And remember, there are no part marks. If you only do it with YZ, or if you only do it with XZ, unfortunately, you lose the marks for identifying symmetry. Okay? Now, If you go that route, then at least do the rest of it okay. Okay, put surface sliders, you know, in the right places, etc. Okay, now, is XY a plane of symmetry? And if not, tell me why. XY is the one that is cutting it like this.
If you're only pulling the top bar up, wait, like when you say plane of symmetry, it's in terms of geometry, right?
No, plane of symmetry means geometry lower than the strength. That's what finite element means. It's not only geometry. In
Okay.
finite elements, all of these must result into symmetrical deformation.
So
It's not only geometry.
the XY plane wouldn't be symmetric because of the deformation on the top. There's only deformation on the top half of the XY plane rather than the bottom half.
Okay, so are you saying XY is a plane of symmetry, or are you saying it's not?
It's not. It
It's
is
not.
not.
That's correct. You're absolutely right. If I was doing this, pulling this thing up by 0.01, pulling this thing down by 0.01, then XY would also be a plane of symmetry. But that's not my problem. You're absolutely right. So this problem, I'm going to do it two different ways. One of them is the way it's done in the book. No planes of symmetry whatsoever, because I want you to see. But then I come back and do the two planes of symmetry that you just mentioned, XZ and YZ, okay? And that's the way it should be on the test, because we're going to say use all applicable planes of symmetry. Okay, so let's move on. Okay, let's start here. We start with the product file. Oops, product. And notice that what I'm going to do immediately, I'm going to change its name, right-click properties. 1, 2, 3, 4, 5, 6, 7, 8, 9, dash. Okay, it's a new week. How about Einstein? I hope this is the right spelling. Einstein. And it is tensile specimen, tensile loading if you want. No planes, no symmetry used. No symmetry used. Just like the book. Okay. Now let's save it. File, save management, save as, desktop, new folder. Okay, so this is lab 53 dash. No planes of symmetry. How about that? No planes of symmetry. Okay, good. Okay. In that folder, we say okay, and we close. Okay, so let us insert the first part. Insert new part in there, and I'm going to call it the block. Right click, properties. 1, 2, 3, 4, 5, 6, 7, 8, 9 dash Einstein. Why don't I call it Einstein? How about calling it block? Okay, block. Good. All right. Oh, I forgot to. This is fine, except that remember I said this is not the part name. This is the instance name. Right click, copy. The part name is down here. What Katia calls part number, actually. Paste. Okay, good. Let's make it. Double click on that line to put us in the part design. Now, this is not the part design. It is the generative shape design, but I don't have any surfaces to do. So we might as well go to the part design, where I can make objects and blocks and things like that. Okay. On that vertical plane, I will sketch something that looks like that thingy. block. And I'm going to make it symmetric, although at this point we're not going to cut it to the XY plane, but might as well do that right now. So let's see now. This one is, let me see the dimension of these things. The height of this thing is 10 inches. The width of it is 4. Okay. And I'm going to draw a circle here. This circle is where that hole is, where the pin is going to go into. What's the dimension of that? The radius of that thing is 0.5. And was that the radius? No. Diameter 1. Okay. And the distance of that to the, okay, 1 inch from here to there. Okay. One inch. Okay. And I'm too lazy to do it, so I'm going to take this thing and mirror it. Mirror this with respect to that. Okay. Exit. Pad it, mirror extend in both directions, because that will allow me to cut it with the plane that I want. The thickness is 1, so you go 0.5 in each direction and you get your 1. Excellent. Let's go there. Now, when I click on the floppy, it will take this part and with that name, save it there in that same folder. You can see that, probably. There's, you see, there, my block, which was my product, and my block. Okay, so let's go ahead in here. Insert a new part. Say no. I'm going to call it the top pin. Right click, properties. Let me call it bottom pin. 1, 2, 3, 4, 5, 6, 7, 8, 9 dash Einstein dash bottom pin. Bottom pin. Okay, bottom pin. Fine. And this copy and paste. Right click, copy, paste. Okay, let's make it. Double click on this. On a convenient plane, on that same vertical plane, I will sketch a circle that size, but it's easier if I projected this, right? I just project that circle onto that plane. There. I don't have to draw it anymore. It's going to be the same size. Now, I'm just reminding you that if you project things, then you cannot go and change the size of that, okay? You have to change the size of the hole to change that. There are ways to fix it. Don't worry about it right now. We don't want it. We don't care. Exit, and then pad it. Now, the pin is 3 inches in each direction. Let's make it mirror extend 1.5. There we are. Now, double click on this, save it. I just want to tell you a couple of things. This top pin is exactly like that. So it's foolish try to make another one and, basically make another one which looks exactly like that. You can use this as once you save it, you can use it again here. You can say existing component, insert existing components, and then, just there's going to be one on top of the other one. You move it, you play with it, etc. However, a word of advice, if the problem is simple enough, go make it. The reason is that when you make an existing component and you do something to the original part, exactly the same thing is going to happen to the thing that you inserted. Okay, so don't do it. I mean, it's up to you. Insert new part. Nope. I'll call it top pin. Right click, properties. I think I already had that name there, paste, except that I'll call it top pin. I know it's foolish if it's exactly like that. Why should I do it? I don't know. You have time, go play with it if you want. Wait a minute, this is the top one, right? Yeah, I have to change this thing. Did I call this thing top? Yeah, I have to call this thing top too. Top. Okay, let's make it. Double click on this line. It puts you in part design. Exactly same story on that vertical plane. I will sketch. Project that circle. There we are. Exit. Pad it in both directions by 1.5. There we are. Now, you go all the way to the top. If you click on the floppy, it's going to save again everything else, which is already saved, obviously, and this one in the folder. And if you look at your folder, well, so many of them here. I think it's this one. You're right here. Yeah, there is the product and 3 parts. Top pin, bottom pin, and the block. Very good. Okay, so everything is made out of the same material, so I can apply material. Let's make it out of steel. On the very top to the assembly, we're going to apply it, and it's going to apply to every single part, and if that's what you have. And save it. Now, let's go ahead to the generative structure analysis. CATIA immediately sees 3 solid parts. It meshes every single one of them right there. See that? It meshed the pin, it meshed the other pin, and meshed the block. Remember, the size of these, the way CATIA decides, depends on the size of the part. This part is bigger, that guy is bigger. Now, well, before I go any further, are there any questions? No questions. Okay. All right, good. Now, I want to show you something. We talked about this thing last time, but I'll do it again because I have every intention of asking you. So I want a finer mesh around this hole. Okay, a finer mesh around this hole. So let me change the rendering here. Okay. So if you look at this toolbar, the second one on the left, there is the local mesh. However, when you click on it, it's waiting you to say, okay, which one of these 3 do you want to refine first? Well, I want to do the one for the block on the top. You see that block right there? The block. Okay. And it says now where? I'm going to say right click that hole. Make sure you pick the hole. And notice that what it did, it probably put a tiny little thingy there. Ah, right there. You see that? Okay. And if you want, you can right click, hide, and that hole. Here, put another one right there. You see this? See this? Don't make it too small because you may be shooting yourself in the foot. Okay, that's better. At least we know you can do it. Now, if you look at your mesh, right-click, mesh visualization, in the middle section, it's that big, but you get close to the ends, close to those holes. You see that? Even if I hit this, okay, let me hide. See, let me put it this way. Right there, you see this? It didn't do any refinement for the pin, but it did it around the hole, okay? I didn't want you to refine the pin, I just said one side, okay? Basically around the hole. I said very explicitly around the hole, in the block, okay? Not the pin. All right, so this is good. Let's deactivate that. Where are my pins? Let's bring them in, right-click, hide and seek. You see, I can hide them individually. If this was an instance of the other one, when you hide one, the other one also going to hide, or the other one also going to show. But the fact that you made them separate means that you can fool around with it as you wish. Okay, now fix this end and fix that end. Okay, and we're going to pull this thing up, these ends up by some amount. Now, in order to pull by some amount, you first make it 0. So you select this face, and you can do the other face too, by the way, simultaneously. Okay? And you say in the direction Z, 0, because I want to change it. Remember, these rotations have no bearing on solid element. You do it, you don't do it, it makes absolutely no difference. Okay? For solids, that doesn't matter. We say, okay, now we're going to apply our load and force displacement on this, and I can put down the number that I want, upward 0.01 inch. I think that's what I said. Okay, good, good. Now, just to show you what happens, well, first of all, let's save our analysis. Don't wait until the last minute. Save management. There is the analysis. Save as. In that folder, this is the right folder. Give it a name. One. Is the paste still there? I don't know. Right click paste. Can I paste? Ooh, that's good. Einstein. So this is going to be assembly. No symmetry. Okay, I'll call it no symmetry. Okay, very good. Say okay. And say okay. If I run, tell me what you expect to happen. We're going to try it, but can you guess what's going to happen if I run? Come on, good guys.
The block will just go through the pins pretty much.
Yes, thank you. Yes, because you have parts, you have to put interactions between them. So here's what you're going to do. Create a general analysis connection. First component, the pin. Second component, hide the pin. Select the hole. Say okay. This is a good place to give it a meaningful name, you know, although there's only two of them that we've got here. So, but here, bottom, how about bottom, bottom, okay, bottom. So that you know what is what. Do another one for the top. So, general analysis connection, select that for the second component, hide this, select the hole, you say okay, and I'll call this thing top, right? Top. Something that reminds me what it is. Very good. And we make these contact. In other words, hey, you block, you cannot go through the pin. Okay? So we make it contact. Same thing with the top. Face-to-face connection right there. The second component, not fasten. Now remember, you can make it fasten, but you know what that thing means. If you make it fasten, it's as if this entire object was either casted like that or machined like that. And I know that's not the case. I bought two pins and stuck it into those holes. That is not fastened. That's contact. So where's that contact? There's the top one. Don't fool around with these at this stage. When you have time after the midterm, after you graduate, you want to fool around with those. So here's the icon for contact. If it was fastened, it would fastener, but this is not fastened. You lose, I'm telling you, you lose marks for these connections, whatever the part marks they have, if you make fasten. It will work. It'll give you color. It'll give you numbers. But nowhere said that these are perfectly welded or bonded together. Okay? Where is that? The other one, here's contact again for this other guy on the top. Now, we are almost done. Because if we run it, it will still bomb out, but not because of what you said. Your analysis was correct. However, it will still bomb out, and you'll see why. Run it. You can see why. Let's animate it. You see, nothing stopped. Let me cancel that. Hang it. Where is the deformation? Okay. Animate. Oh, here, right there. You see, nothing stops this thing from coming out. I mean, if you say in real life, it doesn't come out, because in real life there is such a friction between those two that it will not come out. But if you actually push that hard enough, it will come out. Now, so what we're going to do is we're going to do the following. There's a couple of things we have to do. One of them is making this thing not come out, okay? And let me deactivate this. Deactivate that. Now, obviously, the bottom one does not come out because it was clamped. There's no problem there. So let's, let me see. What are my pins here? These are my pins. This is the top one that you're worried about, right? The bottom one doesn't come out because it's clamped. Now, I'm going to say, for example, hey, you know what? Don't come out. So that user-defined, there's two ways of doing it. One is to go back to that user-defined restraint. Where is this guy? This user-defined restraint. Say, don't move in the direction Y. That will stop it. Okay? I add it to that and run it. It still won't run. You'll see for a different reason. That thing won't come out, but something else happens. Okay, what now? Let's plot the deformation and see what happened now. Oh, it's the block that's moving. That guy doesn't come out. And you can visualize that if this was an ideal world without any friction, the block can move. So deactivate that. Just fix one point of the block, one corner point. Say, hey, you can move this way because this is you know, I'm going to stop it. So one corner point. It doesn't matter which one you put, and just don't move in the direction Y, right? Direction Y. That will take away the rigid body motion. I mean, let me put it this way. If you took the edge and did that, you're going to lose marks. If you took the face and did that, you're going to lose marks. Because when you fix the face or edge, you're doing something else. This is preventing rigid body motion. It's just one point that you need. One point. And you're learning it. I mean, this is not the first time you've done things like this. This time it will run. Oh! Let's see what happened. I didn't expect that. So something else must be going on. Wait a minute. Hang in there. Something weird happened. I didn't expect this. Let me change the scale here. Animate it. Something's. Ah! That pin is not coming out, but it can still go sideways. So go back there to that string and say, don't go in the direction X either. All I'm doing is I'm pulling you up. I won't let you do anything else. I won't let you come out. I won't let you go in the direction X. Okay. So run it again. I forgot about that. This time it will run. Better run. Very good. Okay. Let me reset. Well, first of all, let's look at the deformation. There is reset the scale because otherwise we won't be able to see anything. And there we are. You can see that. Put it in the front so that you can see it better. Okay, so animate. That's what happened. This bottom is fixed. The top one we pull up, and notice that a gap will develop. If this was fastened, you will not let a gap develop here. If it was fastened, meaning it was casted like that, you won't get a gap. These weird things that you see here are the contact elements that are internally created. If you don't want to see it, you can say, just show me the solid parts. Here, look. Let me do that. Just show me the 3D mesh, this 3D mesh. No. Where is that mesh? Oh, these guys. This, show me this, show me that, show me this. Don't show me any garbage. You can see that it won't show you the garbage. See, there's a difference between contact and fasten. Fasten will not let this happen. Okay? And then you can plot the one meso stress, blah, blah, blah. Deactivate. Okay. Anything that you don't like, you can delete. And by the way, you can see why I insisted on having a fine mesh here, because you can see that there is a big stress variation over here, okay? And therefore, you need a fine mesh to resolve these things if you trust these numbers. And I don't, because right now it's 100,000. 100,000 is 3 times the yield strength of the steel. Okay, save everything, because I want to repeat this problem with minimum effort, though. I don't want to do the whole thing. I want to use this stuff in order to cut it. Are there any questions?
Yes, for the block when you made a restraint on just one point.
Yes.
Is that an option? Can I just restrain a surface, a line, an edge, or?
No, because notice what happens is this. By saying 1 point, do not move in the horizontal direction. It means that, okay, it can shrink this way. It should, right? But if you selected this edge and say, don't move, then this edge cannot shrink. It's going to stay the same size, same location. Okay? No. I mean, as I said, it's going to give you color and numbers and things like that, but it's simply wrong. So if you use the edge or if you use the face, and you need 1 point to avoid rigid body motion. Talk to me afterwards. We can go through it if it's still not convincing argument that I'm giving you, okay? Are we good? All right. So what I'm gonna do is I'm gonna do the following. Let me, okay, yeah. Let's do this. And please, look, if it's too much to ask to do it like that, spend the time yourself, make the parts. Again, it's up to you. Here's what I'm going to do. I'm going to say file save management. I will take, you know what? Actually, what I'm going to do is I'm going to kill this analysis, because the analysis, I want to do it for you again. I'm going to kill this analysis, but everything else is there. And then I'm going to say file save management. See, the part and the product and the 3 parts are there. So I'm going to say save as, this is the product, in a different folder. So new folder. This is lab 53 with symmetry. In other words, take that product and put it in this folder. Put it in this folder, which has nothing to do with the old folder. Symmetry. Okay, very good. And I say okay. And anything, by the way, you don't like, you can take away symmetry. These I'm going to leave it the way it is, okay? It says no symmetry, but that is not the case. Say save. But here, say save propagate directory. In other words, take the parts and also put it in that folder. So there will be no interference between what I do now and what I have already done. See that? This was the original one. This is no planes of symmetry, and the analysis is in it, right? The one that I just made is here, just the product and the 2 pin. It's unfortunate that I gave this thing name. Don't do a right click and rename it like that. You have to do it with file save management. If it's bothering you, don't right click and say, take this no symmetry away. You have to do file save management, save as something with a different name, okay? I'm not going to worry about that. Now, let's go there and let's start. Where's my other pin? Pin, hide and show. Okay, good. Get the saw out. We did. And down at the bottom left corner, it says select the plane that you want to cut it with. Oh, okay, I want to cut it with this. It says all of these are going to be affected. Are you sure you want them? Oh, yeah, sure I want them. And it doesn't matter what site I pick. There we are. Do it again. This time you told me YZ, right? Right, like that. And then it says all of these are going to be affected. Are you sure? The answer is yes. Which side? I don't care. Wait a minute. Cancel that. I want to make sure I pick the right plane. It's this plane that I wanted. That one. Okay. All of these. Sure. Do it. Right there. Didn't you say YZ and XZ? We did it. Okay. So save it. This will not affect the stuff that you already put in that other folder. We go to generative structure analysis. It's the second chance for you to see this. Okay. Let me remind you that I made a mesh here, local mesh here. I don't like this rendering. Okay, so you click on it. It says which one? Well, it's this one that I wanted to find, right? From the tree or, excuse me, from the tree or from the screen. And where? I'm going to hide this. There. And I'm going to hide this. There. And I was happy with that size. Okay. Would you like to see the mesh now? Right-click mesh visualization. There we are. There is my pin. And there is the, you see, there is the block with local mesh refined. Okay. All right, good. So deactivate this. Okay. Let's get the pins out. Here are the pins. Hide and show. Is there a question? I mean, look, if you want to ask me a question, just speak up, because I don't know, are you asking your friends or are you asking me? I'm not sure. Okay, good. So let's go ahead and clamp the bottom. Clamp that. Only one side. There is no other side. Okay. Planes of symmetry, which means surface slider. That little circle there. That whole block. That circle on the top. Turn this thing around. That guy. And this little square on the top. And this. And that. And that. These are all surfaces that have been introduced because you claim that it's a plane of symmetry and you made a visual cut there. Good. Now, this guy cannot move out anymore. Remember, it was moving out because you put surface slider here, it cannot move out. So a lot of the problems that we've ran into, some of the problems that we ran into are not going to happen anymore. So, for example, this edge, all I have to do is to go, hey, move up. That's all. It won't come this way. It won't go that way. So all I want to do is to say, if all I say is move up, 0 is going to work. That did not happen last time. We had to go and fix it twice. And we're going to change that to 0.01. Right? Don't divide it by 2. Don't multiply it by 2. You're pulling this thing up. It's 0.01. It's going to be 0.01. Connection between that plane, that surface. Hide that. The inside of the hole. Okay, this is the top one. I didn't call it, I didn't give it a name. Another one. Again, the surface. For the second component, let me hide that. The order of these are not important. You can do the inside face and then pin out next. And these are both going to be contact, right? So they're here. They're here. It's easy to reach it through the tree. Right there. Where's the contact guy? There's the contact guy. This is the bottom one. Well, this was the top one, actually. You see that? Right there. And bottom. Contact. Where's it? Right there.
Pardon me, Professor. I just have a quick question.
Yes.
So I'm trying to log into CATIA through the remote access to the CEI 2105 computer lab.
Yeah.
And
yes.
when I open CATIA, there's a problem with the license for it on the school computer. It says you have not requested a configuration or product license. Click OK and select at least one configuration license. I select that license and it still doesn't work. I'm not able to log in.
Okay, it could be that the guy who's supposed to look after it, they have to reset it. Okay, but the way you're describing it to me, it has nothing to do with you. Okay, they screwed up. So please, the guy's name is Mark Gryn, Gryn. Just send him an email saying that CATIA is not working. I need it. All right, that's not your fault.
Sounds good.
Professor, I think this is like a very common problem. Like sometimes I can't even get into CATIA.
Well, I understand what you're saying. If you're concerned about the test, that guy is supposed to be on duty 12 hours on that day. And I'm going to have direct line with him. Okay? I believe you. I believe you. But under the circumstances right now, nothing can be done. We just have to make sure that this guy is on top of things and he is going to be available that day. Okay? And I sympathize with you. Yeah.
So just really quickly, one of the other students recommended that you wait for OneDrive to load completely before trying to open CATIA, and apparently that is supposed to help fix that problem as well. So for anyone else who isn't looking at the chat, that might be useful to you.
That's a good point. I had no idea. I don't know what you're talking about either, but I bet the other guys know. but please, please, those of you who are experiencing this thing, send an email to Mark Gryn saying that something's not working, because he's the one who's. You see, on that day, on the day of the test, Mark has to go to school because he has to make sure every single computer in the lab is physically on. He has to go flip the switch in case there is a power shortage on that day, for example. These are going to go off, and then somebody has to go there and make sure every computer is on. Okay, there are issues like that. Let's be optimistic. All right. All right, let's move on. Yeah, I think this will run. Did I make a contact? Yeah, I mean, and we're going to run it because I still have to do that last problem for you. It's going to be very quick. It's already on YouTube, but that's okay. And it doesn't affect you guys, by the way. But there is something else that I will mention. All this is saying is that these elements are probably too big, but it did run. Okay, there we are. Okay, and animate. There we are. It's exactly the same thing. Half of it is done. Any question on this before we move on to?
Yes.
Okay, go ahead.
So since we did the planes of symmetry, 2 of them, and added sliders, we don't have to restrict the pen in all directions. We just restricted it in the
because
Z direction.
remember, that's right. Because remember, it was coming out before because the other end of it was loose. Right now, you put surface slider. There is no way this can go to the right because it says, "Hey, you're on a roller. You can't go to the right. You can't go to the left."
Oh, I get it. Okay, thank you.
And then on this side, it cannot turn because it is on the surface slider. See that? It cannot turn going to the left or to the right either. We didn't have that when we did the full model. Okay. Now, before I do the last problem for you, file, save management. Let's see now. This analysis, this has to be saved, right? This has to be saved. This is the one with symmetry. So save as. It's in the right folder, but paste. Analysis. Einstein. Full symmetry. Full symmetry means both planes of symmetry. That's what I mean. Now I want to show you something here. Okay, so let's check our folders. Let me kill this. I don't need this. And I don't need this. Okay. Today, I do 2 problems for you. The first one, let me kill this one too. The first one with no planes of symmetry. A folder of itself, no planes of symmetry. There was the product. There was the 3 parts, 2 pins, top and the bottom, and the block, and the analysis with it. No symmetry used. Then I did a different folder where I called it with symmetry. Remember I said propagate the directory? I didn't put the analysis in there, but I put the part. Unfortunately, this name does not agree with what we have. We can change it, but not by right-clicking. Don't do it like that, okay? And the parts, when they were cut, they are cut. And the analysis, which I didn't carry over here, I saved it again right now. Now, these things, all of them, you submit to the GA for homework, and on the day of the test, if this was the problem that you had to do, you will go, where is it? Oops. Oh, here. You will go to Blackboard. Now notice that here it says section 53, okay? Now the guy who was supposed to do this thing didn't complete it for 53 and 54, but he did do it for 52 and 51. Let me show you. Suppose, pretend that you're in 51 and 52, okay? Just pretend there for a second. So, okay, there we are, home, 51 and 52. If you were in 51 and 52, you go to your 51, you're in lab 51, you go there, you see all those 5 files. If there were question 1, they go here. If all those 5 files were for question 2, it goes there, etc., etc. The GA has not done that, or the head GA has not done it for labs 53 and 54. He has created these, but he has not put these contents in it. Okay, all of them. Any one of them missing, you're going to be in trouble because we can't assess your work. Any questions before I do my last problem? Any questions? Okay, okay, good. So what I want to do is this problem for you. It's not going to take more than, more than 10 minutes. I can guarantee you that. But by the way, it is already on YouTube. Okay, it is already on YouTube. Now, not here. There's the problem. You're given some dimension, aluminum strip, steel strip. These are perfectly bonded together. Perfectly bonded together somehow. I don't know, some adhesive. The end is clamped, and you raise the temperature of the whole thing by some amount. You want to know what happens here. This is the idea behind bimetallic strips, okay, thermostats, okay? And it says use all applicable planes of symmetry. In the book, this is coming from the book. I did not use any planes of symmetry, but in the YouTube tutorial for Lab 54 that I put it up there, I use symmetry, but I want to show you how it's going to work, okay? You look at this, you immediately should realize that this has to be done with solid elements, okay? So quickly, let's go ahead and do that. We start with the product. I'm not going to save the stuff, okay? So with your permission, I'm not going to save stuff. Bad idea. It just takes a few seconds, but we're taking our chances. Okay, so insert new part in there. This top one, the part 1, I'm going to call aluminum on the top. So let's make it. Double click. On a convenient plane, on that horizontal plane, I will sketch a rectangle. Since I'm going to be using symmetry, I have 2 choices. Either make half of it or cut it. That's entirely up to you. Yeah, I'll make. And I'm not going to worry about dimensions here, okay? Because you can always watch the video tube and find out the YouTube and find out what the dimensions are. Okay, you pad it. There we are. This is going to be my aluminum. I'm going to apply material to it. This is the top piece. Metal, aluminum on that. Not on that, on the part, not on the assembly. Okay, good. You can see it right there. Insert a new part. Oh, you have to be, to insert a new part, you have to be in the assembly. Double click, insert new part. This is going to be the steel piece. Let's make it. On that same plane, I will sketch, but I'm too lazy. I'm going to project that on that, and this is going to be the thing that I'm going to pad. This is going to be pad. Same height. In the other direction, this is going to be the steel. Okay, let's make it out of steel. Where's that metal? Metal, steel on that part. We say okay. Done. So now we're going to go to generative structure analysis. CATIA sees 2 part, immediately it meshes it. These can be horrible elements because as far as the size goes, I'll leave it like this. I just want to show you the process. And in basically 5 minutes, if you want to see what was done, watch the video now, because that's 15 minutes, okay? All right, so we don't want to do any local mesh refinement. Everything is good. So let's go ahead and, oh, you know what? I forgot to cut it. Did I forget to cut it? Okay, no problem. I can go back here, use the saw. We'll cut it now. We'll cut this with the middle plane. Doesn't matter which side. Oh, you know what? I went to the part. Let me undo this. Let me undo this. I went to the part and cut it. If I go to the assembly and cut it, both of them can be cut at the same time. If you don't like it, just go to the part. Yeah, that's good. Simultaneously, they both cut. Now we go back to our analysis, which is still down here. I didn't do anything with it yet. Move this thing. It understands that it was cut, so it uses it. Okay, clamp, 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 clamp. This end is clamped. And this end is clamped.
Can't we make another cut?
No,
Another
because this strip,
symmetry?
there's only one plane. There's only one plane of symmetry here. Where's that? Just look, clamp here. If this was clamp and clamp, you're right. If there was a clamp here and a clamp here, there would be another cut. But this piece is free, can go up or down. That's how thermostats work, right? Now,
Oh,
if this,
I get it.
Yeah. All right. So okay. So what else? Oh, connection. Now these two are perfectly bonded together somehow. So right click, hide, bottom, first component, second one, bring that other guy into the show mode. We'll bring it. Okay, good. Okay, so hide this top. This is a hassle, but you have to be careful here. This guy, okay, and this is, tell me, fully bonded, welded. What kind of connection is that? What do you say? What's
the difference between bond and weld?
To us, it's the same thing. No,
Okay.
I said there's something else. There's something else. For example, contact, stuff like that. If it's fully bonded, in parentheses, welded, okay? In parentheses, surfaces welded somehow together, okay? Then it would be fastened. That's what I'm trying to say. It's not contact. If you make it contact, they're going to slide on top of each other. A thermostat does not slide on top of each other in bimetallic strip. So this is going to be fastened. That was my point. Don't use contact. It'll work. It's wrong. As simple as that. There we are. Now let me bring this other part into the show mode because we have to apply the load now. The load is due to the temperature effect. So you look in here. You look in the loads. The only thing that looks like Dr. Rankin is right here. Okay, so temperature field. So it's a body force, a body entity. So we're going to make a temperature rise of 118 Fahrenheit. No, actually, it's not 118. Look what it said. Not there. It says uniform temperature rise of 50 degrees. That means above the room temperature. Room temperature is ordinarily 68 degrees Fahrenheit. So add 50 to it, you get 118. That's where this is coming from. And I'll show you how to adjust that if needed. You apply temperature here, you apply temperature there, you say okay. Now I want to show you something here. As soon as you click that temperature thingy, what happens in the tree, you get something called environment. This was not here before. As soon as you click that guy, this thing pops up. If you double click on it, it says what is your reference temperature. Now, if you don't like this, you want to make it 0, fine, make this thing 0. But room temperature is the reference temperature. If you don't want, you want to use something else, no problem. I could have done 0 here and just added 50. Not added 50 to 0. The effect is the same. Finito. Let's run it. Something I forgot. Big time. big time. Surface slider. You cut this thing. So on that face and on that face, surface slider. No part marks. I almost lost, I don't know, 5, 6 marks, 7 marks, I don't know. But at least I did the other ones right. Shouldn't expect a full mark if I make a mistake. It's rather unfortunate, but there we are. And the reason is that the coefficient of thermal expansion of aluminum is bigger. It tries to grow more, and the steel says no.